Okay, friends, so I want to expound a little bit, and only for a couple minutes here, on what it means that the ones and twos and threes show up as often as they should. All right, so in Excel, I have created a random number generator. Actually, Excel already has a really good one called rand between, if you look at that command up there. What it does is it has Excel, it basically throws a three-sided die, and it gives you either a 1 or 2 or a 3, depending on which side is facing up. So this entire brick of numbers right here, I think I put 100,000 or so in this brick. Every time I re-randomize by pressing the F9 button, I get 100,000 more dice to roll. 100,000 more, 100,000 more, 100,000. These look very similar to those sequences that you saw on the exam of the ones and the twos and the threes. It's probably pretty hard to distinguish what you're seeing here from what you're seeing there. We'll get around to that as we go through the problem. Now, what I mean by they're showing up as often as they should, if I scooch over here just a little bit, I've got a little frequency distribution and a corresponding percentage distribution. What this does is it keeps track of how many of each of the digits are showing up in the brick of numbers to the left. So for example, there are 34,306 ones, 34,145 twos, and 34,149 threes. And if I re-randomize, those numbers change, but Excel keeps counting them. There's a really cool command, we'll learn it here at some point, called COUNTIF that I'm using to do that. And then in the column next to that, I just have the percentages. So right now, in the current reload, we've got 33.4% ones, 33.6% twos, and 33% threes. If I re-randomize, the percentages change, but you'll notice that those percentages are staying pretty close to 33%. And I've actually got a visual here for you in pie chart form. That pie chart is indicating the three percentages that you see in that last column there. Now, if I keep re-randomizing, if you look very carefully at the pie chart, you'll notice that it's changing in a very minuscule way with each re-randomization. But that pie chart is effectively broken into three equal pieces. Yes, with experimental error, a little bit different. Like if I stop right now, I've got a 33.3, a 33.5, and a 33.2. So at this moment, there are a few more twos than there should be. But that's, again, sampling. Even though it's a huge sample of 100,000, it's still sampling, which means there's still going to be a little bit of error. But effectively, the error has shrunken away to something that we can ignore. And we're getting 1/3 threes, 1/3 twos, and 1/3 ones, which is exactly the number you'd expect from, you guessed it, a uniform distribution. If this really were a three-sided die falling, and Jenny was using the three-sided die to pick her numbers, you would expect the same frequency of ones and twos and threes. And that's what you're seeing right here. Let's check Jenny's sequences against these 1/3s.